all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at one of the methods of course, solving for systems of linear equation, and this is going to be involving the concept of elimination method. Now, the various steps which I've basically listed on the board are going to assist us in trying to perform this specific procedure. And they are going to consist of 4 basic steps which I've just given in terms of a summary form. And this is going to be assisting us try to shorten the lengthy process which is involved in this particular case. But I'm going to be explaining one step into another, and this is going to be, of course, assisting us in trying to solve this specific system of linear equation in terms of course, this elimination method. Now, in a sense, we are going to see that there are other subsequent methods which we are going to be using in trying to solve this system of linear equations. And these are going to be constituting of methods of the Gaussian elimination method and, of course, the Gaussian-Jordan elimination method. And we shall look at those specific types of methods in an exclusive way, which is going to assist us try to contrast this one. Now, in a sense, we're going to see that the Gaussian elimination method and the Gaussian-Jordan elimination method are going to be 2 specific methods which are going to be making it, of course, convenient for us in trying to find solutions of these specific equations. And later on, we shall look at another method which is going to be involving what we refer to as the Cramer's rule. Now, in a sense, I've just mentioned this range of methods which are going to be assisting us find solutions to systems of linear equation. And in a sense, this is going to be our topic of discussion or interest for now. But later on, we shall look at Gauss's elimination. So this is going to be Gauss's elimination method, which is going to be partly the concept of elimination, but we're going to see that this is going to be involving the use of echelon matrix that has been reduced to echelon form, which basically is going to be consisting of these specific elements which we are going to see for the coefficients of their known values of either x, y, and z. Now, in a sense, we're going to see that we're going to use the concept of the augmented form in this specific case for the Gaussian elimination method. And for the second case, we are going to see that we are going to involve another additional method, which is going to be the Gaussian-Jordan elimination method, which also is going to be consisting of an augmented form of a specific matrix, but which is going to be involving reducing a matrix to a row-reduced echelon form, which is going to be employed in this specific case. Now, for the 2 methods, we are going to see that the augmented form of a specific matrix is going to be, of course, reduced to echelon form and row-reduced echelon form. And lastly, we shall look at the concept of what we refer to as the Cramer's rule, which is going to be employing the concept of determinants in trying to, of course, find the specific values for the unknown, of course, variables over x. Now, in a sense, we're going to see that the 4 methods are going to be employing different concepts, but we're going to see that rather these specific methods are going to be more convenient as compared to these general methods that we're going to look at. But it's going to be, of course, essential for us to learn the various steps which are going to be creating a basis for us in understanding the subsequent methods. Now, in a sense, we shall look at this specific method, and the strategy of elimination method basically is going to be entailing elimination, or rather eliminating one variable at a time by performing what we refer to as elementary row operations. And these are going to be step-by-step procedures which are going to be involving, of course, some operations which are going to be assisting us in trying to, of course, find the solutions for this basic equation. Now, these are going to entail multiplication of one equation by a non-zero constant. And in this specific case, we are going to see that this non-zero constant is going to be perhaps given in terms of a k, which is equivalent to a non-zero given as such. So this process is going to be entailing the multiplication of one equation by a non-zero constant, which we are going to see particularly using the specific equation which we have just given on the board. And we can also achieve this by performing what we call interchanging the equations. And lastly, we can perform an addition of what we refer to as a constant multiple of one equation to another. Sorry for that. which also going to be forming part of the procedure. So addition of a constant multiple of a specific of one equation to another. We can rather have it one equation to another. So I hope these specific steps are going to be comprehensive rather. Now in a sense, we are going to see that these are the basic 3 steps which we are going to be using in trying to, of course, change this specific form of a linear equation for us to obtain what we refer to as the various variables of x, y, and z. And this is going to be involving the concept of elimination. Now I've stated that basically we can achieve this by multiplication of one equation by a non-zero constant, which is going to be, of course, more elaborate from the, of course, evaluation which we are going to do. And then we can interchange the equations of this specific system for us to, of course, achieve results which we are, of course, going to be looking for their known values, which of course are going to be forming the variables. Now we can as well add, perform an addition of a constant multiple of one equation to another. And this is going to be, of course, more elaborate from this specific example which I've just given on the board. That's going to be assisting us do the same. Now this is going to be a series of steps which, as I said, are going to be consisting of step 1, 2, 3, and 4. And this is going to be involving this particular system of linear equations which are going to be equation number 1, 2, 3, which forms this specific system. Now I'm going to read through this equation in case there's one that's not legible, then it's going to be, of course, okay for us. So equation 1 consists of x plus 2y plus z equivalent to 4. And then we shall have equation 2 given in terms of 3x plus 8y plus 7z is equivalent to 20. And the last equation is going to be formed by the, of course, this is specific part of 2x plus 7y plus 9z is equivalent to 23. Now we are going to perform this, of course, steps which are going to assist us eliminate one variable at a time. And of course, we're going to use the various elementary row operations which I just mentioned. So the first step is going to entail the use of addition, which I've basically said that we're going to perform an addition of, we're going to perform an addition of negative 3 times the first equation to the second one, which is going to be our first step. So the step 1 is add negative 3 times the first equation to the second. So this negative 3 times 1 to the second. So we're going to evaluate the value of negative 3 times the second equation, or the first equation, which is going to be given in terms of x plus 2y plus z, which is equivalent to 4 given as such. So this is going to be giving us a value of negative 3x plus 6y plus, so this is going to be, of course, a minus due to this specific sign. So we shall have negative 3x minus 6y minus 3z is equivalent to negative 12. So the first step, as we have said in step 1, is going to be adding 3 times equation 1 to equation 2. So this specific evaluation is going to be giving us a result of this. And this result, we're going to be adding it to equation 2, of course, equation 2 given as such. Now equation 2, so this is going to be a transformation of equation 1 from the first step. And then we shall have equation 2 given in terms of 3x plus 8y plus 7z is equivalent to 20. So an addition of the two equations as per this specific procedure is going to be giving us 0 plus. So this is going to be giving us plus 2y. And then we're going to have plus 4z is equivalent to the value of 8. So in a sense, this is going to be involving this specific equation 1 and 2. And we're going to see that the result we're going to obtain is going to be resulting in transformation of equation 2 from this specific previous, of course, form of 3x 8y plus 7z is equivalent to 20. And we're going to have in the first step equation 2 transformed to 2y plus 4z is equals to 8. Now the first equation and the last equation are going to be maintained as such. Now from the first procedure, then therefore we're going to obtain a set of equations represented by a step 1 given as such. So then we shall move to the step 2 and try to see what are some of the, of course, values which we are going to obtain. So for step 2, we're going to perform another operation, a elementary operation, which I said, which is going to involve the addition of a negative 2 times the first equation to the third. So this basically is addition of negative 2 times the first equation to the third given as such. So first we're going to evaluate the negative 2 times the first equation, and this is going to be giving us the value of this specific equation, which is going to be giving us this is x 2y plus z equivalent to 4. So the value of that one is going to be giving us negative 2x and minus 4y minus 2z is equivalent to minus 8. So this is the value of adding of negative 2 times equation 1 to equation 3. Now equation 3 is having the value of 2x plus 7y plus 9z is equivalent to 23. Now in this case, we are going to perform an addition, which has been given by this specific step, and this is going to be giving us a 0. And therefore, we are going to look for this second term, which is a negative 4 plus this one is going to be giving us 3y. And then we're going to have negative 2, which is going to be giving us 7z. And the answer for that one is going to be giving us 15. Now, basically, it's going to be a transformation of this specific nature, where we're going to involve this particular form of a transformation of equation 1. And then we're going to be, of course, adding this one to equation 3 given as such. And this is going to be resulting in the transformation of this specific equation 3, which we have seen in this particular case. That is going to result to a value of the second part, which is going to be 3y plus 7z given as such. And this, of course, is going to be assisting us try to transform equation 2. Now, in a sense, we're going to see that still we're going to remain with two specific variables of the unknown. And therefore, we will perform a subsequent step, which is going to be assisting us remain with one variable, which is going to assist us, of course, define others through the process of back substitution. Now, in a sense, we shall perform a third procedure, which is going to be involving step 3, which I mentioned. Sorry for that. Now, step 3 is basically going to be involving division, whereby we're going to divide equation number 2 by 2. So in this case, we are going to see that this specific results which you achieved from the second procedure is going to be involving a division of this equation 2 by, of course, 2, which means we are going to have this specific equation. So the equation number 1 and, of course, 3 are going to be maintained, which is going to be the result of procedure number 3. And therefore, this is going to be half the quantity of this specific value, which is going to be y plus 2z is equivalent to 4 given as such. And then we're going to perform a final procedure, which is going to be involving step number 4, which basically is going to be involving us a subtraction of equation 3 from 3 times equation 2. So we're going to subtract. So we're going to perform a subtraction of equation 3 from 3 times this specific equation of 2. So for us, we're going to obtain this specific value of 3 times equation of course, which is going to be 3 times equation 2, which is going to be 3 into y plus 2z is equivalent to 4. So that's going to give us a value of 3y plus 6z is equivalent to 12. So we're going to perform an operation of subtracting equation 3, this one, from 3 times equation 2. So this is going to be forming our value of a subtraction of 3y plus 7z is equivalent to 15. So a subtraction of the two equations are going to be giving us 0. 6 minus 7 is equivalent to negative z is equivalent to 12 minus 15 is equivalent to negative 3. So basically, this is going to imply that we are going to have a form of equation given in terms of a negative z is equivalent to negative 3. So this further implies that z is equivalent to, of course, the value of 3 given as such. So this specific step is going to be assisting us find this particular, of course, value for the value of z. And as we can see from this specific point, we are going to be starting to perform a back substitution for us in order to obtain other specific values. Now, this is going to be resulting to a step number 4. And therefore, we are going to perform a back substitution method or involve a back substitution method for us to obtain the values of course, y and x now that we have obtained the value of z. Now, in a sense, I'm going to have this one given in terms of z is equivalent to, of course, this specific value of 3. And then we shall have this one for the second equation for this step number 4, we have y plus 2 times the value of z, which is 3, is equivalent to 4. So this implies that we can have y given in terms of 4 minus 6, which is equivalent to negative 2. So the value of y is equivalent to negative 2 given as such. And of course, we can perform an evaluation for the first equation for us to obtain the value of x, which is x plus 2y plus z. So we are going to do a substitution for this one. So the value of y is equivalent to negative 2 plus z. The value of z is equivalent to 3, is equivalent to 4. So x minus 4 plus 3 is equivalent to 4. So we'll take this one, the other side, x is equivalent to 4 plus 4 minus 3. So x basically is equivalent to the value of 5. So x is equivalent to 5. So in a sense, we have used this specific concept of elimination method in trying to solve for the individual values of x, y, and z. And this is going to be consisting of those specific elementary row procedures, or elementary row operations, which are going to be assisting us moving from this, of course, step 1 to 4, of course, which are going to be assisting us find the specific values of x, y, and z using those specific, of course, elimination of one variable at a time. So in a sense, this is going to be a lengthy process. And of course, as I said, the subsequent operations of course, other methods like the Gaussian method, elimination method, the Gaussian-Jordan elimination method, and the Cramer's rule is going to assist us try to have another perspective of trying to solve this system of linear equation. So kindly check out description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for a range of updates on different discussion we do in math and sciences. So that is it for now, guys. By God bless you. Catch us in our next video.